Hello students. So in this video I'm going to give introduction about unit number 4, coordinate and measure tool metrology measurement. So this is the syllabus for unit number 4. So it's all about introduction to coordinate metrology and difference between conventional and coordinate metrology. Then what is meant by coordinate measuring machine, what are the components available and its types, and measuring head types and types of probes will be discussed. Then again, another half is about alignment test in machine tools, various machines like milling machine, drilling machine. Simple examples will be discussed, and also how we can able to do the calibration of CMM. We'll be checking along with the applications of CMM. So this lecture, the content, what all the things available in that presentation material is from different sources, and you can use this only for just for reference purpose. And please read textbooks for more how to write content, okay, for exam point of view, but concepts you can understand from this lecture. Okay, let's move on to the topic. So if we're talking about metrology or measurement, it's basically all about inspection. So why we need measurements, particularly for inspection? So in terms of inspection techniques, we'll be having contact inspection and non-contact inspection, where contact will be physical contact and non-contact means non-physical. Physical or non-physical inspection or measurement techniques. So basically instruments, what are the instruments you might have came across during our lab, a steel rule, micrometer or vernier caliper, vernier height gauge, go gauge, no-go gauge, or other sign bar, dial gauge kind of things came, and comparators, profile projectors like that. So all these measurement techniques you can able to classify according to the nature of measurement, either it comes under contact type or non-contact type. Okay, contact inspection in sense there should be a mechanical probe, there's a mechanical probe or other way that makes contact with the object, the physical contact with the object. The purpose of the probe is to measure or gauge. It will be performing for two operations, one to measure, another to do the gauging. Measure is like measuring original dimensions of what is there in that component. But gauging is to compare. Maybe in terms of mechanical comparator or electronic comparator, you know that we'll be using some dial indicators, fine. But it's also useful for measuring also possible. Okay, so instruments can be used for measuring purpose and also comparing purpose. If the same instrument used to compare between with the standard value with the what we are measuring, then it will be called as a gauging. So contact inspection is usually concerned with some physical dimension of the part. Okay. So mostly where we will be using this contact inspection technique includes manufacturing industries mainly, like machining of metal pieces or stamping or other metalworking process. For example, if we are making gear making process, we'll be using contact type inspection technique, like dimensions. Or if you do lathe operation, turning operation, you will be measuring the diameter of the workpiece. Or if you measure like a number of holes, if you are making holes, you will be measuring the particular hole features diameter, internal diameter, how much. Thread, if you are making thread, you will be measuring. Okay, so manufacturing industries, mostly people will be using these measuring techniques. And also in medical industries or other pharmaceutical industry also they'll be using measurement technologies, maybe weight or mole or something, that is different measurement technique. But in terms of instruments, what we consider like all other instruments we saw in our lab will be comes under mechanical or metalworking or manufacturing related industries. And CMM and related techniques to measure mechanical dimensions possible. And stylus type surface texturing measuring instruments also there. Maybe surface roughness testing machines like roughness or waviness measuring instruments also, you know. That also comes under contact type inspection technique. Then what is the counter portion for contact type is the non-contact inspection technique, where they will be using sensors to measure certain distance from the object, that also useful for measuring or for gauging purpose. Here, contact type also useful for measuring and also for gauging. Similarly, non-contact inspection also useful for measuring and also for gauging purpose we can able to use. Under non-contact inspection technique, you will be having two types. One is optical inspection, non-optical inspection. So what is optical in the sense where you will be using light. Okay, that light will be used to measure or to gauge. Okay, most important optical technology example we can say is the machine vision. So last unit number three, we partially discussed about machine vision. So you'll be using a camera and also you'll be using different light sources and also position of the lights also different types are there. So by using lights and through camera we can capture, we can do like a shorting operation, or we can able to identify distance or diameter of the particular feature, circular feature kind of thing. For measuring purpose also we can use and also for gauging purpose. So in optical inspection technique mainly what to say, the light is primary source for measurement. In another type under non-contact is non-optical inspection technique. This also useful for measuring purpose. For example, it won't use light, it will be using some forms of energies. Okay, what kind of energies? Electrical fields or radiation or ultrasonic energies they will be using and measure or inspect it. Okay, so for example in casting process, maybe you might have remember in your manufacturing technology you studied about casting. So in casting is what you will be having a cavity under the cavity. The cavity is made up from the casting process. Like you will be preparing a mold and that you will be putting pattern and remove the pattern. After that you will be having the cavity, right? In the cavity, if you are pouring a molten metal, then after giving solidification time, then solidified, you can take the casted part out. Then you want to see whether any defects available, not outside. Internally, there is a defect. How to check? Maybe there is a process you might have studied about eddy current process. In eddy current part, you will be sending some current through the cross section of your casted product. Then it will be received, and the another end will be identifying that is there any defect inside the casted product. Okay. So electrical fields will be used in that. So using that process also we can do uh, inspection. So that will be comes under non-contact and also non-optical inspection technique. Okay. So to all together, inspection technique classified into contact and non-contact. Okay. So continue further in terms of non-contact inspection, this will provide you better advantage comparing with the contact type inspection. So directly we can't say that contact type inspection is poor comparing with the non-contact. No, this non-contact inspection providing little bit advantages comparatively, but inspection also has better advantage comparing with non-contact. This is just for explanation. You could understand from the explanation that the non-contact type inspection could avoid damages to the part surface that might result from the contact inspection. Sometimes the component being measured maybe get some defect or damage. Uh, it may be due to the improper orientation of the measurement tool and holding the component. So that will affect some defects on the surface of the uh, product being tested or inspected. So that may cause from the contact type. Then inspection cycle times are inherently faster in terms of non-contact inspection compared with contact. For example, if you want to measure like 1,000 components and its diameter, so if you are using micrometer or if you are using vernier caliper, so you need to take it and move the both the jars and put it over the workpiece and see the reading manually and check it. Maybe the digital indicator is there, then you can able to see the values in different resolutions. Okay, but the time taking process comparing with the non-contact. In non-contact, for example, as I said, optical system you are using, machine vision you are using, 1,000 components is going in line in the chain, in the conveyor. directly keep some machine vision system, and automatically you will be capturing the images and comparing with the setted standard images, whether it's accept or reject. We can able to find out easily instead of using manual. So contact comparing with the contact in this kind of example, on contact inspection will be providing faster measurement. Okay, and sometime in contact type inspection you need special handling of tools, okay, to for special purpose, for measuring the company. For example, you have to put it under the jigs and fixtures and measure. But here, like in conveyor, it will be traveling, maybe conveyor in the left side oriented, right side oriented, or some other places in conveyor. You can just compare with the case studies, okay, then only you can able to understand how it is better. Okay, so example, based on this kind of example, on contact is offering better measurement speed. Okay, that's it you have to take. And also it is more flexible to conduct 100% automated inspection. Yes, people are moving with automation or Industry 4.0, in the sense you need to have a faster inspection technique where this non-contact inspection will give some edge over the contact type inspection. Again, you have to think about whether it is feasible to implement, whether it will be affecting, but it is for not for short run. It should be for the long run. Long run in the sense, here I am telling about long run in the sense, it's all about how many number of component you are manufacturing for how many number of years, or how much order you have. In that sense only I'm telling. If you are having only 1,000 components being manufactured and supplying to some sub customer, and you will be changing, then further you no need to automate it. Okay, so it's all about the feasibility, profit loss calculation and all will come. So this is the basics about the contact and the non-contact type inspection techniques. Then comparison. In terms of comparison between contact and non-contact, you will be using different methods: manual measurement, measurement using conventional metrology, or measurement using coordinate metrology. If you have coordinate metrology, you can say it's a CMM or related technology. Conventional metrology in the sense micrometer, linear vernier scale, or vernier height gauges kind of things will come under conventional metrology. So this chart drawn between PQ. P is representing parts variety, Q represent the parts quantity. So it's drawn between the variety versus quantity. Okay. So here, if you have the part quantity is less and part variety also less, so you no need to invest for any automatic process over there. Only using manual measurement and the gauging process, you can able to complete the inspection process. Okay, so it's all about quantity and variety. If the quantity is less, variety also less, then you can go with the manual measurement and gauging. But if you increase the quantity, but keeping the variety same, like some numbers, same fixed one, then you have to go with the manual and semi-automatic, because completely manual is not possible because quantity is little bit higher. So you have to go with the semi-automatic measurement technology. Also, you have to use it. Okay. Then, if you have a parts quantity very huge in volume, okay, number, then you have to dedicatedly you have to use some automatic measurement technology like a machine needs to be implemented here. So if you keep your part variety low, if you are significantly increasing from the quantity from some numbers to next number to next number, then you have to changing, or you will be updating, or you will be implementing in your industry the semi-automatic to the automatic. In automatic, definitely you will be using machine vision technique. But in other cases, you are not you are going to increase the variety of component. Okay, maybe different features will be added on the basic component in the basic size or shape of the component. In the sense, when you are increasing the variety, then manual measurement or semi-automatic is not sufficient volume. You need to have some coordinate measuring machine, because coordinate measuring machines will be providing you the better measurements for variety if you have more. So motor driven man and manual. So CMM will be classified into multiple ways in terms of operating procedure, whether computer controlled or manually controlled or motor driven or mechanical assisted, motor driven, like the multiple cases are there. But variety is there means mid-level variety is there, motor driven and manual CMMs can be used. But if you go with the more number of variety, volume is less, volume of component you are going to be manufactured is less, but you are going to have a more number of variety in the sense you have to have a direct computer controlled CMM. Under this direct CMM, computer controlled CMM, how it goes means, for example, if you want to check the connecting rod, or if you want to check the, you want to inspect the piston or connecting rod or engine valves kind of thing, you know the 3D model of your component, right? So what you have to do is you have to feed the 3D model of the product to your computer, which is being connected with your CMM machine. So the software which is available with the CMM will read the diagram or part model, 3D model, and accordingly the coordinates will be calculated and will be given input to the probe. Probe in the sense through the machine control unit it will reach the probe. Probe only going to contact with your component. Okay, either probe maybe contact type or non-contact type also there. Maybe if they use some light sources then non-contact. But mechanical probes may be there in different shapes of probes also there. Circular, semicircular, conical type also there. We'll be discussing in coming slides. Okay, that kind of probe will be receiving the input. That probe head will receive the input from the machine control unit according to the design of your component. Okay, then it will be moving accordingly and inspect whether original dimensions given as per the diagram is met or not. If it is not met, it will reject. Okay, so if you have a more variety, then you have to go with comparatively more variety means significantly more variety means you have to go with the direct computer control CMO. Less, little bit lesser means go with the more motor driven and manual CMO. If variety is very very less, then you have to go with the manual measurement and gauging. So these are all the overall inspection technique. But if you have a mixed variety and mixed amount of quantity in the sense, you have to go with the inspection, flexible inspection. Sometimes you can use CMM, sometimes you can use semi-automatic type. Okay, it depends on what is the features available, how many number of components. So it's you can't say it's a high variety or you can't say it's high volume. It is in mid range in the sense we have to use both either CMM and also semi-automatic type gauging system. Okay, so this is all about inspection technique. And this is like a trend or evolution of your measuring instruments. Started with the qubit. Qubit, it's like a scale kind of thing. Ancient time they will be using qubit. It will be represented in terms of one length or feet kind of things. Okay, it's also like a kind of scale only, but it's a little different. Ancient time they will be using that. And then other things you know that micrometer, you know, gauge, blocks, you know, length comparators you guys are using, and gauges and dial indicators you guys are using. Then machine visions, profile projectors are universal measuring machines, and CMM. So CMM also you guys saw a demo in our robotics lab. So these are all the development came in that multiple classes, subclasses also there. But outset started with qubit, and like it's kind of steel rule you can say. Next level from qubit to the next level is the steel rule. Steel rule in the sense they made a standard to universal standard, like a 1 feet scale kind of thing they prepared, then micrometer, all this go. So this is the evolution of measuring instruments. Then comparison between conventional and coordinate metrology. So you know conventional metrology basically scale or vernier caliper, micrometer. But coordinate measuring machine based on the coordinates, 3 axis XYZ, they will be able to measure and give you. So in conventional metrology, it will be manual and takes lots of time consuming alignment of the test workpiece. But comparatively, comparing with conventional metrology, coordinate metrology is a bit easier. Okay, alignment of the test piece not necessary. Directly you can keep it on the table of any coordinate metrology machine and you can able to measure. Single purpose and multi-point measuring instrument make it hard to adapt to changing the measuring task. Okay. But a single adaptation to the measuring test by software, because coordinate metrology inbuilt with some computers and dedicated softwares are there, so you can able to use it for different purpose. Either for measuring like a dimensional feature or form features also you can able to use it. Okay. Then comparison of measurement with material measures, that is gauge block. Comparison of measurement with mathematical. So here they will be using like a gauge blocks, all the things will be available in terms of conventional. But in terms of here, they'll be using some mathematical models. They will be preparing some mathematical equations in coordinate metrology. Okay, so you need a separate determination. You have to separately determine the size, form, location, orientation in terms of conventional. But in coordinate metrology, all in one. The particular software will provide you with a single measurement. Okay, once that system is on, the probe is touching, it will be recording all the coordinates, XYZ coordinates are from the component. Then it will be telling you that what is the size, what is the form, or what location it is there, and also what kind of orientation. So all will be provided by the coordinate metrology machine. But though investment is higher comparing with the conventional metrology, but at the outset you will be getting better yeah, outputs or better data from the coordinate metrology. Okay. Then overview of coordinate measuring machine. I think I can start this topic in the coming uh, next video. So as of now, we have basically discussed about what are all the types of inspection techniques available, contact type, non-contact type, and how it is developed. So what are the advantages of conventional metrology over, and what is the advantage of coordinate metrology and the difference between them we have discussed. Okay, so I'll stop this video recording. We'll continue in the next recording.